The multiplication of fractions is almost as easy as the multiplication of integers. If I am multiplying a over b times c over d, all that I have to do is multiply the numerators a times c and divide that by the denominators b times d. The only additional step that you have to perform sometimes is that you're going to have to simplify what you get as a result. But apart from that, it is just the same thing as multiplying integers. In this video, I will do a few examples of multiplying fractions and multiplying fractions with integers. As we said before, when you're multiplying two fractions, you just multiply the two numerators and divide that by the multiplication of the two denominators. Now, when we are multiplying one fraction with an integer, let's say a over b times c, you can rewrite that c as c over 1 and follow the same rule. It becomes a times c divided by b times 1. So what we have is a times c divided by b times 1, which is simply a times c divided by b. b times 1, b multiplied by 1 equals b. So if you're multiplying a fraction with an integer, all you have to do is multiply the integer by the numerator of the fraction, and all of that goes divided by the denominator of the fraction. A divided by b times c equals a times c divided by b. Now let's look at this simple example here. We will substitute the values of a, b, c, and d. A will be 2, b will be 3, c will be 5, and d will be 8. So I want to multiply 2 over 3, which is a over b, times 5 over 8, which is c over d. All that I have to do is multiply 2 times 5 and divide that by 3 times 8, which is what I'm doing here. That becomes 2 over 5 is 10, and 3 times 8 is 24. I'm sorry, I mean 2 times 5 is 10, and 3 times 8 is 24. And I can simplify that dividing by 2 both on the numerator and the denominator, and 10 over 24 becomes 5 over 12. This is the final result. If I want to verify that that is correct, one thing that I can do is first perform the division of each one of the fractions and then multiply them later and see if I also get the same result as I was getting on the other side, first multiplying, then performing the division. Let's just do it here. 2 over 3 expressed as a decimal number is 0.6 with the line over the 6, meaning that that is a recurring decimal, so that is 0.666, an infinite amount of 6's. 5 over 8 is just 0.625. And again, from the previous example, we see that 2 times 5 is 10, 3 times 8 is 24, so we have 10 over 24. So this side has to be equal to this side. Let's verify that. 0.6 recurring multiplied by 0.625 equals 0.416, and the 6 on this side is also recurring, so I have 0.41 and an infinite amount of 6's after the 1. And again, I simplify 10 over 24 and it becomes 5 over 12. And if you perform that division, you're going to see that 5 divided by 12 is also 0.416 recurring. So we see that no matter how we do it, if we first divide each one of the fractions, and later multiply them together, or we first multiply the numerators and the denominators and later divide them, we're going to get the same result. Now let's multiply a fraction with a constant. In AB times C, A will be 2, B will be 3, and c will be 5. So it becomes 2 over 3 multiplied by 5, or 2/3 multiplied by 5. Following the rule, I just multiply the 2 times 5, the numerator times the constant. 2 times 5 becomes 10, and the denominator stays in the same position. So it becomes 2 times 5 divided by 3, which is 10 divided by 3, and that is an improper fraction where the numerator is larger than the denominator. I can change that to a mixed fraction, or sometimes called a mixed number, which is this right here. 10 over 3 equals 10 and 1/3. This is the summary of what we did. 2/3 times 5 equals 3 and 1/3. Verifying that the same way we verified the previous exercise, we see that 2 over 3 is 0.6 recurring. When I multiply that times 5, I get 3.3, and the 3 is also recurring. So this is 3.333 all the way to infinity. On the other side, 2 times 5 divided by 3 is 10 divided by 3, and then if you divide that, 10 divided by 3, you can do it in a calculator. That is also 10.3333 infinite, which is also expressed as 3 and 1/3, which is what we had in the previous example. So if you first divide 2 over 3 and then multiply it by 5, or if you first multiply 2 times 5 and later divide that by 3, no matter how you do it, at the end of the day you get the same result, which is 10 divided by 3, or 3 and 1/3. So remember the rules for the multiplication of fractions. If you're multiplying two fractions, just multiply the numerators and divide that by the multiplication of the denominators. And if you're multiplying a fraction with an integer, just multiply the numerator times the integer divided by the denominator. Thank you for watching all the way to the end. If you found this useful, please subscribe, tell a friend, and don't forget to check some of my other videos and the playlist. Once again, thank you, and see you on the next video.